Life Code Unlocked. That is the title of this passage. Life Code Unlocked. So let's see what we can do with this set of questions. We have matching heading questions from 1 to 6. Okay, then 7 to 9 we have true false not given. Then 10 to 13, we have gap filling or summary completion. Okay, so let's identify some keywords, okay, in the headings. The search, number one says the search for the better fit matching between the model and the gained figures. Okay, better fit is a keyword for me here. Better fit. To foresee the activities of the genes. Okay. Definition of Medusa, okay? A flashback of commencement for a far-reaching breakthrough. Flashback is a keyword here. Maybe somebody's thinking about something that happened in the past. A drawing of the gene map. Drawing is a keyword here, then gene map. An algorithm used to construct, algorithm is a keyword here, construct a specific model, okay, to discern the appearance is a keyword here, of something new by the joint effort of Wiggins and another scientist. This is also important. An introduction of a background tracing back to the availability of mature techniques for detailed research on genes. An introduction of a background tracing back to the availability of mature techniques. Availability of mature techniques for detailed research on genes. Availability, okay? Mature techniques, okay? A way out to face the challenge confronting the scientist on the deciding on researchable data, okay? Deciding on researchable data. So that's the challenge that the scientist was facing. A failure to find some specific genes controlling the production of certain proteins. A failure to find some specific genes. Failure is a keyword here. All right. Number 9, the use of means from other domains for reference. Other domain from another domain. Another domain. That's a keyword for me here. A tough hurdle on the way to find the law governing the activities of genes. Tough hurdle. All right. So let me read the passage paragraph by paragraph. You can see that they've done paragraph A for us. So I won't waste too much time reading paragraph A. I'll just go straight to paragraph B. And I will know that I'm not using statement 3 again. Paragraph B says, instead of shirking from this question, the 36-year-old applied mathematician and physicist at Columbia University embraced it. And now, 6 years later, it thinks he has an answer. By furrowing into fields outside his own. By furrowing into fields outside his own. That's sounding like another domain. Where is that statement about another domain? Number 9. Okay, so let's just finish it up and be sure that the remaining sentences will point at this issue of what that man did outside his domain. By foraying into fields outside his own, Wiggins has drugged up tools from a branch of artificial intelligence called machine learning to model the collective protein-making activity of genes from the real-world biological data. Engineers originally designed these tools in the late 1950s. Which tools? The tools that Wiggins used. Okay, they use it to predict output and input. Widgets and his colleagues have now brought in machine learning. That's what they are calling these tools. You can see that they use machine learning here for widgets. Okay, so I've now brought in machine learning into the natural sciences. Can you see another domain? And tweaked it so that it can tell a story, not only about input and output, but also about what happens inside him. I think paragraph B can be matched to this statement. Number 9, the use of means. What's the means? Machine learning. From another domain. What's the another domain? AI, artificial intelligence. You understand? So paragraph B, number 1, will be matched to statement number 9. All right, paragraph C now. The impetus for this work began in the late 1990s when high throughput techniques generated more mRNA expression profiles and DNA sequences than ever before, opening up a completely different way of thinking about biological phenomena. Wiggins says, hold on. Where's that one about mature? A background, introduction. You see, they say this work began. That they are introducing something. This work began. Then it says introduction of a background tracing back to the availability of mature techniques. Mature techniques for what? Detailed research on genes. Let me see. Research on genes. DNA sequences is a paraphrase for genes. Anytime you see DNA sequences in science, in biology, in IELTS materials, just know they are also referring to genes. So DNA sequences that never been opening up a completely different ways, a completely different way of thinking about biological phenomena. Key among these techniques were DNA microarray. Okay, so this is what they used. Chips that provide panoramic view of the activity of genes and the expression levels. Can you see genes is showing up here? Activity of genes, panoramic view, and the expression level in any cell type, simultaneously and under myriad conditions. As noisy and incomplete as the data were, biologists could now query which genes turn on and off. Well, this talks a lot about what happens with genes. So it connects very well with this issue of research on genes. Which other heading talks about genes? Let me check. Number one, the search for. This number one is talking about the search for something. This paragraph C does not talk about the search. It's about what happened in the past, what they did in the past. So this number one looks close, but because of this word search, and then it says they gained figures. I can't see any mention of figures here per se. Figures talks about maybe 200, 300,000, 10%. Those are figures. So, Medusa did not show up in paragraph C. They've used number three for us. Gene map. And this word map did not show up in paragraph C. Map. Gene map. Then drawing. A drawing of the gene map. No. Let me just go with my number five. Number six. Number six, I'll match number six to paragraph C. Now, paragraph D. Yet, predicting such gene activity requires uncovering fundamental rules that govern it. Rules. Hold on. There's one statement about law. Look at this thing here. Find the law. Find the law governing activities of genes. A tough order, let me see. Predicting, let me look for that tough order. Yet, predicting such gene activities requires uncovering the fundamental rules that govern it. Over time, these rules have been locked in by cells, says theoretical physicist. Evolution has kept the good stuff. To find these rules, scientists need statistics to infer the interaction between genes and the proteins that regulate them. So you see, this whole thing is showing up all the way. All this part I put in color blue. I've seen them already. This part of Tofodo. Let me be sure I will see that part. So then to mathematically describe this network's underlying structure, the dynamic pattern of gene and protein activity over time. But physicists who did not work with particles or planet for that matter view statistics as nothing short of anathema. What is meaning of anathema? Anathema stands for something very difficult or very bad. Let's check. Let's look at Google for the meaning of anathema. Okay, look at it here. Something or someone that one vehemently dislikes. Can you see that? Something that someone vehemently dislikes. So nothing short of they dislike it. Can you see why? Can you see that tough audio is showing up now? So paragraph D can be matched to statement number 10. Paragraph D can be matched to statement number 10. Somebody says, are we going to be able to use dictionary on the exam day? No, you will not be able to use dictionary. I'm teaching something here. That's why I use dictionary. As a matter of fact, I have an idea of what this word means. You understand? So, but I just wanted to show you to see the meaning. I knew that this thing was a negative word. I knew when I saw it that it's a negative word. And if it's a negative word, then it should refer to something, it should refer to a tough. You get my point? So this part of vocabulary, this part of the benefit of practicing reading, lots of reading passages, it helps to build up your vocabulary. Okay? Now, paragraph E, But in working with microarrays, the experiment has been done without you, Wiggins explains. And biology doesn't hand you a model to make sense of the data. A model. Model, I saw model somewhere. See this model here. The search for the better fit matching between model and the gained figures. Okay, let's go on. So it says that what? And biology doesn't hand you a model to make sense of the data. Even more challenging, the building blocks that make up DNA, RNA, and the proteins are assembled in myriad ways. Moreover, subtly different rules of interaction govern their activities, making it difficult, if not impossible, to reduce their pattern of interaction to fundamental laws. Hold on. That last question I did. Fundamental, see this law again. Wow. A tough hurdle on the way to find law, to find one law governing the activity of genes. This one says laws. Hold on, let me check that last paragraph. To find these rules, yeah, they use the word rules. Similar. Wow. Let me go on. Now, so some genes and proteins are not even known. You are trying to find something compelling about the natural world in a context where you don't know very much. You are forced to be agnostic. Wiggins believes that many machine learning algorithms perform well under precisely these conditions. So yeah, they describe the challenge. And then towards the end, he now says that what machine learning can help out. Hold on. This one just talks about the tough hurdle. It doesn't address the issue of machine learning helping out. That other heading, this number one, the search for the better fits. The better fit matching between the model and the gained figures to foresee the activity of genes. This paragraph E and D and E, they look somehow. Let me just, I hope I'm not, I mean, by the time I check the answer, I hope they will not say paragraph D is 1 and paragraph E is X. I'm not sure. Let me just leave it at that. Paragraph F now. At the Kavli Institute, Wiggins began building a model of gene regulatory. See, model is showing up again. You see, this number one here, this word figures, gained figures. I didn't really see it in paragraph E. Let me see if I will see it in paragraph F. Wiggins began building a model of gene regulatory network in yeast, the set of rules by which genes selectively orchestrate how vigorously DNA is transcribed into mRNA. As he worked with with different algorithms, he started attending discussions on gene regulation led by Christina Leslie, who ran the computational biology group at Columbia at the same time. Leslie suggested using a specific machine learning tool called classifier. Say the algorithm must discriminate between pictures that have bicycles in them and pictures that do not. A classifier sifts through labeled examples and measures everything it can about them. From these rules, the algorithm, hold on. Number 5, the algorithm. Can you see algorithm here? Because I'm seeing algorithm showing up like I've seen it 3 times now or 4 times. An algorithm used to construct a specific model to discern the appearance. Yeah, Wiggins and another scientist, that other scientist is this Christina Leslie. So let me match paragraph F to statement 5. Paragraph F to statement 5. Then paragraph G. The algorithm that Wiggins and Leslie began building in the fall of 2002 was trained on DNA sequences and mRNA levels of regulators expressed during a range of conditions in yeast, when yeast was cold, hot, starved, and so on. Specifically, this algorithm, Medusa, that's the name of the algorithm. What's the meaning of Medusa? Motif element discrimination using sequence agglomeration. Scans every possible pairing between a set of DNA promoter sequence called motifs and regulators. Then, much like a child might match a list of words with their definitions by drawing a line, Medusa finds the pairing that best improved. So this paragraph G here, did they define Medusa? This thing says definition of Medusa. But this paragraph, this is the only part that gives us the definition of Medusa. So can I pick this based on that? Is there any other heading I've not used? Have I used number one? I've used number one. Number two, I've not used it. Number three, a flashback. Okay, they've used number three already. Number four, I've not used number four. An algorithm used to construct. I've used no. Number four is drawing of of the gene map. No, that can be. This can number four can be matched to paragraph G. Number five, I've used it. Number six, I've used it. Number seven, a way out. A way out to face the challenge confronting the scientist on deciding of researchable data. Ah, deciding of researchable data. Let me see. Look at this thing here. The hierarchy of numbers enables Wiggins and his colleagues to determine which pairing are more important than others. Enables Wiggins and his colleagues to determine which pairing are more important than the others. This thing says deciding of researchable data. Wow. I think I will match this paragraph G to statement number 7. Number 7. Let me match it to number 7. I'm really not sure, but I'll just pick number 7 for it. So let's go to the next set of questions. Wiggins is the first man to use first man. They didn't mention whether I was the first man. Hold on, where's microarrays? But in working with microarrays, the experiment has been done without you. Microarrays has been in existence before Wiggins. Hold on. Um, where is I saw microarrays somewhere. See microarrays here. Key among these techniques were DNA microarrays. So it was not the first. They've been working with microarrays before. So this one is false. Number 8, there is almost no possibility for the effort to decrease the pattern of interaction. There is almost no possibility for the effort to decrease the pattern of interaction between DNA, RNA, and proteins. Pattern of interaction between DNA. Let me look for DNA, RNA, and proteins. Pattern of interaction. See DNA here, okay? Even more challenging, the building blocks that make up DNA, RNA, and proteins are assembled in myriad ways. Moreover, subtly different rules of interaction govern the activities, making it difficult, if not impossible, to reduce their patterns of interaction to fundamental laws. So, look at this thing here. Compared to this statement number 8, there is almost no possibility for the effort to decrease the pattern. This word, I think this is a mistake. I'm not sure this word should be decreased. I think it should be something that sounds like figure out the pattern of interaction between DNA, RNA, and proteins. Oh, hold on. Decrease, if not impossible, to reduce. Okay, reduce their pattern of interaction to fundamental laws. They didn't put that part of fundamental laws here. What's going on here? Hey, I will pick not giving. This number 8 is looking like an incomplete stuff to me. Wiggins owns a positive attitude about the future of genetic research. The future. Wiggins believes that many machine learning algorithms perform well under precisely these conditions. Machine learning lets decide. Oh, hold on. See this thing here. Machine learning lets us decide the data that is worth working at. Let's go back to that machine learning. Number 7, paragraph E. Deciding on researchable data. Paragraph E, number 7. I used 1 for it. And I picked 7 for this. Wow, I'm going to change this thing. I'll change it to 7. Then this paragraph G. Hi. I'm going to pick Medusa for this paragraph G. Paragraph G, I'll pick statement 2 for paragraph G. Paragraph G, statement 2. And then this paragraph D. Paragraph D could be X, it could be X, or it could be high. Okay, let's go on. So Wiggins holds a positive attitude on the future of genetic research. The future of genetic research. NUX mode. The future of genetic research. I'm trying to check this paragraph G for anything about future. Medusa can predict which genes ratchet up the RNA production. I'm not sure. This thing, I'm not sure. Not giving it showing up twice. I think I'll change this number 8 to true. I'll change it to true. I always have this feeling that the 3 options will always show up. Sometimes it doesn't happen like that. Sometimes it doesn't happen. But um, when I'm solving, I always want them to show up. I don't know. I just feel that way. Wiggins states that the outstandingly rapid development of techniques concerning the components of gene allows the researchers to look at dash from a totally new way. A totally new way. Ah, a totally new way. Where did I see that? I don't think it's in paragraph A. Paragraph B. Or totally, anything that sounds like a totally new way. It's not in paragraph B. Paragraph C. A completely different way. Okay? Opening up a completely different way of thinking about biological phenomena, Wiggins says. Looking at biological phenomena. Okay? Dash is the heart and soul of these techniques. Okay, let me just continue. Key among these techniques were key. That's DNA microarrays. DNA, how many words? Okay, no more than 3 words. All right. DNA microarrays is the heart and soul of these techniques. And no matter what the dash were, at the same time, they can offer, no matter what the conditions were. Hold on. That can provide panoramic view of the activities of the genes and their expression levels in any cell type simultaneously under myriad conditions. No matter what the conditions were. Conditions. I think it should be conditions because that myriad conditions, that's what it sounds like, no matter what the conditions. They can offer a whole picture of the gene's activities as well as dash in all cell types, as well as what in all cell types, as well as activity of genes. This places gene activity and expression levels in any cell type, as well as expression, gene activities, as well as expression in all cell types, in all types of cells. Expression levels. Should it be expression levels? I think let me just leave it as expression. So let me submit and see what my score will be. Okay. I'm seeing four answers are wrong here. Let's check it out. Number 12 should be correct. This thing that is in brackets means that this myriad is not compulsory. So number 12 is correct. Then this one says, number 13 says their expression levels. Their expression levels. Okay, I think I agree with them, as well as expression. We are not sure whether this THEIR and levels should be in bracket, but it looks like they are not in bracket here. So I think I agree with this. I agree with them on this. Then number 6, the answer is statement 1, not 2. That last paragraph G where we saw Medusa, they are telling me that the answer should be statement number 2. What's statement number 2? Oh, definition of Medusa. Can you imagine? Hold on, no. The answer should be statement 1. The answer should be statement 1, this one. The search for the better fit matching between the model and the gained figures. All right. Then number 7 should be not given. Number 7 should be not given. I think I picked not. There's one I picked one answer and then I changed my mind. Oh, no, this one I picked first straight away. Okay, it's number 8 that I changed my mind. Number 7, they said Wiggins is the first man to use DNA microarrays. Okay, they said the answer is not given. Well, I based my answer on, let me see. So I guess my analysis was wrong with that. So I based my answer on, where is it now? I based my answer on, where did I say microarrays now? On this place here. Key among these techniques were DNA microarrays, chips that provide panoramic view. So I felt that, okay, since this work began in late 1990s, and they said that DNA microarrays were key in the use of this. That means they've been using DNA microarrays since then. I just made that assumption. And that's why I picked first that Wiggin was not the first man. Well, maybe because of this word man. Anyway, there could have been, what's it called, a woman or something like that. We don't know. We don't have much information about whether it was the first man or the first, as they said first person. I don't know. But anyhow, the point is that the answer to number 7 is not given. All right, I'm going to wrap it up on that note. Thank you very much for joining me. Let's watch out for the next lesson.